Hello everyone, welcome to the Sesh Kamal Academy. We have started the lecture series for various competitive examination like GATE, IAS, RRB JEE, SSC JEE and State Services examination. So we have started the lecture series for fluid mechanics subject, and in this video we are going to learn the types of fluid and its a classification. So let's start the types of fluid. So mainly the types of fluid are classified as ideal fluid, real fluid, ideal plastic fluid, Newtonian fluid, and non-Newtonian fluid. Further, the non-Newtonian fluid is classified as the time-independent fluid and time-dependent fluid. So each type of fluid we will learn one by one. Now the first one is ideal fluid. The ideal fluid is that fluid which possesses all the ideal properties. That means the fluid which has no viscosity, the viscosity is zero. There is a no change in density, means change in density is zero. The value of bulk modulus is infinity, and there is a no surface tension. Okay, so this is called as an ideal fluid. But in inverse or in reality, there is a no such a fluid as an ideal fluid. Okay, so it is an imaginary fluid. Now the next type is a real fluid. The real fluid possesses all the properties. So the fluid which has all property like viscosity, density, bulk modulus, surface tension, shear stress. So the fluid is called as a real fluid. And the example of our real fluid is water, petrol, air. Okay, so these are the some examples I have taken here for the real fluid. Then next is a Newtonian fluid. The Newtonian fluid is a fluid which obeys the Newton's law of viscosity. That is, the shear stress tau is directly proportional to velocity gradient or shear strain. Okay, so this is the relation that is derived from the Newton's law of viscosity. If the fluid obeys this relation, we called it as a Newtonian fluid. And the examples of the Newtonian fluids are water, glycerol, motor oil, etc. Then non-Newtonian fluid, the fluid which does not obey the Newton's law of viscosity, we called it as a non-Newtonian fluid. Means the relation came from the Newton's law of viscosity is not applicable to non-Newtonian fluid. The examples of non-Newtonian fluids are butter, blood, toothpaste, paper pulp, printer ink, etc. And to represent the behavior of non-Newtonian fluid, we have a relation for a shear stress is equal to A du by dy raised to power n plus b. These A, B, and n are a constant that depends on the flow condition and fluid type. Okay. Now let us understand the meaning of each symbol. The n is a index or a fluid flow behavior index. Then B is a yield value, and the A is similar to the viscosity. Okay, similar to the viscosity, or it is also called as the consistency index. It is also called as the consistency index, and this equation is helpful to plot the nature of the non-Newtonian fluid. Okay, then the non-Newtonian fluid are further classified as the time independent and time dependent. Now the time independent fluid are like dilatant fluid, Bingham plastic fluid, or it is also called as ideal plastic fluid, and third one is a pseudoplastic fluid. Now let us understand one by one. What is meant by a dilatant fluid? The dilatant fluid is that fluid whose viscosity increases with the increasing shear stress, and it is also called as a shear thickening fluid. It is also called as the shear thickening fluid. And the examples of the dilatant fluid are butter, quicksand. Then second is the Bingham plastic fluid or ideal plastic fluid. Bingham plastic fluid or ideal fluid are those fluid which possess the value of B. Okay, means the ideal fluid or Bingham plastic fluid has some yield value. Okay, has some yield value. And the example for the Bingham plastic fluids are drilling mud, toothpaste, gel, ketchup, etc. Then third one is the pseudoplastic fluid. The pseudoplastic fluid means the viscosity of such a fluid decreases with the increase in shear stress. with the increasing shear stress. And the pseudoplastic fluid are also called as the shear thickening fluid. Shear thinning fluid. Shear thinning fluid. The dilatant fluid are called as the shear thickening fluid, whose viscosity increases with the shear stress. But the pseudoplastic fluid are called as a shear thinning fluid whose viscosity decreases with the increasing shear stress. So these are the time independent fluids. And the examples for the pseudoplastic fluids are paper pulp, rubber, lipstick, paints, blood, etc. Okay, so these are the examples. So these, from exam point of view, these examples are very important. So you have to uh, uh, remember the example of each type of fluid. Okay, then next type or a subclass of non-Newtonian fluid is a time-dependent fluid. Okay, first one is a thixotropic fluid. The thixotropic fluid whose viscosity increases with the time. Whose viscosity increases with time. The examples of the thixotropic fluids are printer ink, enamels. Okay. Then the rheoplastic fluid. For the rheoplastic fluid, the viscosity of the fluid decreases with the time. Okay, decreases with time, because these are time dependent fluids. So thixotropic fluid viscosity increases with time, and for the rheoplastic fluid the viscosity decreases with time. And the examples for the rheoplastic fluids are gypsum water solution and bentonite solution. Okay, bentonite solution. The study of these non-Newtonian fluid, remember the study of such non-Newtonian fluid are uh, done in rheology. Okay, rheology. The study of the non-Newtonian fluid is called as a rheology. Okay, so this term you have to keep in mind. Then the representation of the various non-Newtonian fluids on the shear stress versus shear strain graph. Okay, now we have an equation for representation of these non-Newtonian fluid as tau is equal to a du by dy raised to power n plus b, and we have already seen the meaning of each symbol in this equation. So the graph is plotted uh, shear stress versus velocity gradient du by dy. Okay, and the value of n and b gives the or classify the fluid type. So for example, the value of n is equal to 1 and b is equal to 0. Let us see the representation of such a fluid. Okay, and what the fluid is called. Okay, so such a fluid is called as a Newtonian fluid. Okay, and it has a direct relation between shear stress and velocity gradient. Okay, so if you put a value of n is equal to 1 and beta is equal to 0, you simply get tau is equal to a du by dy. Okay, this is nothing but the Newton's law of viscosity, and the fluid which obeys this relation, we called it as a Newtonian fluid. Okay, now the second condition for value of n now is greater than 1, and beta b value is 0. Okay, means there is a no initial yield. Now let us see the representation for such fluid. Okay, and such fluid is called as a dilatant fluid. Okay, such fluid is called as a dilatant fluid. So the relation for dilatant fluid comes tau is equal to a du by dy raised to power n. The value of n is greater than 1. Okay, so the nature of such fluid is look like this. Now next is the third one, n is less than 1 and value of b is 0. Okay, now see the representation on shear stress versus velocity gradient. We called it as a pseudoplastic fluid. Okay, we called it as a pseudoplastic fluid. Now next is n, value of n is greater than 1, and now the beta b value is not equal to 0. Okay, now the b value is not equal to 0 means the fluid has some yield value, means the fluid has some yield value. Okay, yield value. Okay, the yield value is nothing but the initial stress. The yield value is nothing but the initial stress, and to cause the flow of fluid, the value of shear stress must be equal to the yield value. Okay, means the fluid behavior start from like this because the fluid has some initial shear stress. Okay, initial shear stress. Now see the representation for such fluid. Okay, we called it as a rheoplastic fluid. Okay, we called it as a rheoplastic fluid, and this rheoplastic fluid is a time dependent fluid for the viscosity decreases with time. Okay, so we have till now completed this four representation of for non-Newtonian fluid. Then n is equal to 1 and b is not equal to 0 again. So see, the we called it as an ideal plastic fluid or a Bingham plastic fluid. And the last one, the value of n is less than 1, but b is not equal to 0. Okay, so see, we called it as a thixotropic fluid. Okay, we called it as a thixotropic fluid. Now how to remember this graph, or how to because there may be a little confusion to plot the fluid and name it. So I will suggest to just to go in this direction, or in this from x to y, okay, in alphabetical order. Okay, so if you observe the list of this fluid and observe the first letter, so it is start from D, that is dilatant fluid. After D in alphabet, it comes N, then P, then R, and then T. Okay, then after the R, then T. Okay, so simply you have to just go in alphabetical order from bottom to top, like the I have shown this direction, or okay, with the help of this arrow. Okay, so this is all about the types of fluid and fluid classification. Okay, and in examination, definitely the question were mostly asked on this topic to identify the example of fluid. Okay, some example is given, and you have to find the you have to find out the type of that fluid. Okay, so hope this video will be helpful for you, and if you like, if you gain something from this video, definitely don't forget to like and share. Okay, thank you so much.